Hello everyone and welcome to Dividing Radicals. So the first one is the square root of 15 divided by the square root of 3. The interesting thing here is if you were to look at 15 and 3, they both actually divide evenly. So you're allowed to just take the square root of 5. 5 is coming from 15 divided by 3 is equal to 5. So whenever you can, if the two numbers divide evenly, you should just divide them and then leave it in the square root symbol. So in this case, it's equal to the square root of 5. And that's my answer for that one. So please make sure you copy all these questions. It's not in the packet, so you just need to write them down. Okay, then we're going to go to the next one. Number 2. In this case, it's talking about the square root of 15 divided by the square root of 16. The interesting thing here is that 15 is a non-perfect square, but 16 is a perfect square. So you're going to leave the square root of 15 in the numerator, and you're going to break out the square root of 16, and it's going to become a regular old 4. So the correct answer here is the square root of 15 over 4. You always want to look for perfect squares. In this case, this 16 is a perfect square, so you take the square root of it, and it becomes a plain old 4. Okay, the next question, number 3. Here we have coefficients and we have radicals. So just like before, you want to divide the coefficients now instead of multiplying them. You're going to divide the coefficients. So 10 divided by 5 is equal to 2. And then, right after that, you're going to divide the radicals. So radical 18 divided by radical 6 is going to be radical 3. And believe it or not, that is your final answer. So the black 2 comes from 10 divided by 5. The red 3 comes from the two radicals being divided. And the final answer is 2 radical 3. The next one, number 4. I'll give you a second to copy that. Okay, now we're going to look at this one. So this is an interesting case. We are again going to divide the negative 30 by the 6 and get negative 5. Then we are going to divide the 48 by the 3 and get radical 16. So the interesting thing here is the fact that the square root of 16 is in fact a perfect square. So this is going to break up into a 4, and we're going to times it by negative 5. And then my final answer would be negative 20. Okay, that's question number 4. The next one, number 5. Now, in this case, we're simply going to divide the coefficients and divide the radicals. So when I divide 20 by 5, I get 4. And when I divide 14 by 7, I get rad 2. And that's my final answer. Now you might be thinking, why are these so easy? Well, they're going to get a little more difficult. So watch this one. In this case, we are going to divide the 20 by the 5, and it's going to become negative 4. And we are going to divide the 60 by the 3, and it's going to become radical 20. Now, unfortunately, you're not done, because radical 20 could get broken down into 4 and 5, which is 2 root 5. And when I multiply it by negative 4, I wind up with my final answer of negative 8 root 5. So that's the correct answer there. Notice this one required a little bit more simplification when you thought you were done. Okay, and then down to number 7. So in number 7, we have an interesting thing here. It doesn't seem that 10 divided by 3 works out so nicely. It's not an integer, and it's certainly a crazy long decimal. So in this case, and in this case alone, you have to rationalize the denominator. Now, before we do that, we can certainly divide the coefficients. So this would give me negative 7 root 10 over root 3. Now, when I rationalize the denominator, and this is from previous lessons, you're going to multiply the top and the bottom by root 3. And this answer is going to be negative 7 rad 30 over a plane 3. So think about that for a second. Negative 7 rad 30 over a plane 3. And think about it for a second. The negative 7 just stays. Rad 30 you're going to get from 10 times 3. And the 3 on the bottom, remember rad 3 times rad 3 gives you a plane 3. So the correct answer is negative 7 rad 30 over 3. This example was different, and it's very important that you realize that it's different in this case because right here, the 10 divided by 3 does not work out so nicely. In the other examples, when we did any kind of division, 14 by 7, or 60 by 3, 48 by 3, 18 by 6, 15 by 3, or even in this case slightly different, but we wind up having to rationalize the denominator when it does not divide evenly. Okay, and let's take a look at this one. In this case, we are simply going to divide the coefficients again and get negative 1. We're going to divide the radical 280 by radical 10 and get radical 28. And we are not finished because radical 28 could get broken up into 4 and 7. So my answer is negative 1 times 2 times root 7, which in essence is just negative 2 root 7. So excuse me, these are 8 different examples. The next slide is going to be some notes that I would like you to copy. So let's take a look at that. In the second slide, basically I have the notes that I want you to copy. So you're going to divide the coefficients and then divide the radicands. If the numbers under the radicals divide evenly, then certainly divide and simplify. And if the numbers under the radicals do not divide evenly, then rationalize the denominator. Please make sure you have those 8 questions copied, as well as these 3 lines of notes, and I'll see you tomorrow. Thanks.